All right, we're live. I updated the stream description there. Totally forgot to do that before I started, but yeah, today it's not my usual stream. I'm gonna just work on some Advent of Code, stuff like that, and see where we get. So welcome, I'm Agent Ultra. On this stream, usually on my usual nights, I stream on Tuesday evenings, and I do stuff in functional programming. But it's that time of year again where we have Advent of Code out. And this year, for some reason, I decided to choose Chaos and attempt it in C. So let's get on with day 3, shall we? So day 3's problem was to basically find the largest digit you can make, at least part 1. To find the largest digit you can make with just picking 2 integers out of this string. Basically, you get a string, an unsorted string. You're not allowed to sort the string. All right, so you got to pick the two largest you can. All right, so you can't reorder the numbers, the digits you find as you're investigating them. Perfect algorithm for like a greedy kind of algorithm. Perfect problem for a greedy kind of algorithm. What I mean by greedy? Well, it's basically like just doing the most optimal thing you can. It's like a game, right? Doing the most optimal thing you can on your turn, given the information you have. Not caring about long-term strategy, not caring about finding the most efficient path, right? Because then you'd have to like investigate all the possible values and it could be really, really slow. Or it can be fast depending on what data structure you're using, but like you can't sort this and stuff like that, so it's going to be a bit of a problem. So greedy works really pretty well here. So I solved part 1 yesterday. I was pretty busy yesterday, so I didn't have time to stream or anything like that, but I didn't get to part 2. So I'm going to work on part 2 this morning. And yeah. So let's look at the code. So far, what we have is max joltage, the greediest of algorithms. Yeah, my strategy was to initialize the digit I'm going to make and basically do a sweep through the string, looking for the largest digit I can get, largest tens digit. All right, so hopefully we get a 9 or an 8 or a 7 or something like that. Whenever we find a digit larger than the one we currently have, I just update this largest I, this index here, so that we know what index it was. And then do another sweep right after. So the code goes from I plus 1, the largest I plus 1, the next index after the largest one we found so far, to the rest of the string, and tries to fill in the second digit. And we return that. Oh, and this sweep here, this terminating condition goes like to the end, the one character before. So in that kind of last case where you have the two digits at the very, very end of the string, right? You want I to end before that. You don't want to get the very, very last digit. That's that. It's pretty good. All we do is get our numbers from our input, read them into a buffer. This was embarrassing. It took me the longest time to figure this out. And I had noticed, I had like a bunch of print statements in here and like checking all the indices, and I had all the tests passing just right, but it was failing on my input. And it was so annoying because I was like, what the heck is going on? I had written little helper functions to try and detect like bad numbers that I wasn't calculating properly and all that kind of stuff so that I could debug this. And I had like all of these like weird kind of like I was like, why isn't it finding the right number? And I'd tweak this little number to be like 3 or like 2. Turns out it's because and I had not noticed this for the longest time. That fgets was including the new line string, the new line character that it was breaking on. So you have to strip it out. And once I did that, I was like, oh, I simplified everything. I was able to like compress the code down and like, oh, okay, now everything works. It's part 2. Part 2. What is part 2? Always a twist to these. So now, same as before, but this time, instead of just 2 digits, we're going to get bigger ones. 12? 10? 2? How many? 12 digits. Yeah, that's it. So the voltage output for the bank is still the number formed by the digits of the batteries you've turned on. But now we're looking for 12 of them instead of just 2. Okay, this is going to make things a little bit more interesting, as always. So I think first things first, we're just doing a little refactor. We'll try and get this to take in the number of digits we're going to collect as a parameter. And we'll just get it to work with 2 so that we can solve the original problem. And then we'll figure out how to make it work with larger values, I guess. So, we'll do size t of digit len. Okay, dynamically allocating stuff. We have this nice, like, hard-coded 2 in here, statically allocated, super nice, great. Can't do that at runtime. Yeah, so we have to come up with a way of allocating this. Or we can, like, say, you know what? You're probably not going to select n greater than... Or we could just make max joltage 12. I don't mind that we hard-code it, I guess. Or we dynamically program it. It'll probably be fine. Because the only thing we have to do is free it when we're done. So that should be easy. Okay, let's do that. Make it a pointer to an array. So an array of cars. Digit. And we need a digit len bytes. And I want to zero them out like we had before, but I don't think we can just do that. All right, mem set. Yep. Just be a little... We probably could throw caution to the wind here. It's just a puzzle, but whatever. You know? Might have to typecast the void. I'll make that 0 and digit len. Okay, and then we're just going to remember to free it before we do that. So we'll get our... They're going to be much larger this time, so we should probably do uint64 for the results. Which will mean we need stir to LL. Base 10. And we want to A... No, we don't need A to I for that anymore. We could just return results. Then we can free our temporary digit result array there. Okay. And let's see, what else? This will basically practically ignore our argument here and still work for the first part of the puzzle, at least. So if I'll set my directory again. File. Yeah, I need more arguments there, so let's just put 2 for now. Okay, that works, and 276 isn't right. Am I running this? Yeah. I did change it to stir2ll. Gotta change the return type. And sum is already that, so that's good. And so I'm saying 2 digits, maybe. Excuse me. Need just one more. Then digit len. Maybe stir2ll needs us to have a string terminator. I don't know. I could read the documentation on it, but let's just try this quickly. So mem set everything up to digit len, and then we can set digit len +1 to the null byte. Although that's going to make our calculation, that should be fine. Let me stash these changes for a sec. Yeah, okay, we did make a weird change that it doesn't like. Okay, so what did I do to change the result here? Changed the type to uint64. We gave it the size t digit. And although we should probably make it more like int digits or something. Because the length of the string of digits is going to be potentially a little bit different. Although in my usage of A2I here, we didn't have a a null byte. We just had 2 bytes, which was fine and works well. So that's probably a little unnecessary. Maybe I gotta read up on stir2ll. Right, converts initial part of the string, yeah, to a long integer value given the base argument, which has to be between 2 and 36 inclusive. While the special value is 0. The string may begin with an arbitrary amount of white space. Yeah. Yeah. In the obvious manner, stopping at the first character, which is not a valid digit in the given base. If end pointer is not null, then it'll tell you where that is and all that stuff. Stir2ll just returns the long integer value. Unless the value would underflow or overflow. We might need to check for those error cases sometime, but maybe more like in the sum case. As long as these values we pass in are too big. We don't have to get super generic. If this isn't going to like pan out, then we can just specialize and like do a pip-day2 function. And just hard-code it to 12 digits. Okay, so let's try and figure this out. I'm going to change that to not size t, like int. We can be more specific, like uint 8. Okay, so then we don't need to do that. Or we shouldn't need to do that. Oh, because we're zeroing out to the 0 character. Right. That's why. My algorithm is using the fact that the digit characters are, at least in ASCII, ordered accordingly, that the comparison operators still work on them. So I could set like I do for largest I on the second pass and put a non-digit character there in order for stir2ll to work. Stirtol? Yeah, C has a lot of funny names in its standard library. And I think that's probably where the meme of, you know, being bad at naming things comes from. Okay, so why don't I try that? Okay, and then after we're done, we set digits largest I plus 1 to be equal to, say, the null character. Oh, sorry, that's digit. No, still 276. What is happening? Mm, 19 isn't right. 7892. Dynamically allocating digit is going to be tricky. What if I just make it a dash? Well, it's yeah, it's printing it out a little bit weird because like it's not really a string. It's a string. I print you out. Result. That's what I really care about. I think print the num2, but that's changing behavior a fair bit. So somewhere in this change, just by changing digits to be dynamically allocated here, result 19 is kind of odd. Oh, did I maybe modify how this was set up? Yeah, maybe I got to initialize. I removed an initialization here. A digit. Maybe that's what I did. And I accidentally moved it on. There we go. Okay. We're back. Silly things like this. You know. You gotta be super careful and super precise when you're doing C programming. Okay. So that refactor, let's commit that. Doesn't do anything yet, though. We're not quite done. but I'll make it a work in progress commit. Dynamically sized digits. Okay, so now the next step is to fill in the owl. Of course, right? We got our 2 circles. Okay, no, so really now we gotta actually work on we have to work on the problem now. So, okay. So in our little game now, instead of just finding 2 digits now in 2 passes, we've got to work on finding up to a certain number. We've got to do a certain number of passes to find the rest of the digits. All right, so our game is to do the most optimal, beneficial thing we can at the given moment, right? So always increasing the tens column is the first place column is always the best thing we can do. That's always going to yield the biggest number that we can get, isn't it? Well, let's check our input and test that theory. In this case, easily, right? It's the first number, we hit a 9. Any number we build off of that is going to be great. This one, not so much. We got to be a little bit more careful, right? If I was to do, well, my current first loop here to find the largest tens digit, the largest first digit, right? Goes up until the second last character here. I think we just need a new constraint here. It's not the second last character, but it's numlen minus our digit length we got to go up to. So if our digit length was, say, 3, right, we want to reserve these last 2 digits as possible candidates. And so we have to like this idea of like a reserved space, it feels like, is what we need to do. So optimally, we need to go through as those digits up to that point and still look for the biggest first digit we can make, leaving space for the remaining candidate digits we can select from. Let's try that theory on this one. All right, so our digit size is like 3. All right, so we got to reserve at least 2 digits off the end. Let me do this with my pencil here. Yep. Make this a bit bigger. This a bit bigger. There we go. All right, so we got to reserve like at least 2. All right, and so in this part here, I is going to sweep through and try to find the biggest number it can get. 4, looks like. Now, it's possible from this 4 here, the first one, that we might find our largest digit. Right. In this kind of like reserved area after the 4. We could find our digits somewhere in there. But we also know that we could find a bigger number for our first digit if we keep going up until the end. So we'll still do the last I strategy. I think that will work. But we might need to back would we need to backtrack at any point in time in our game? Like, if I scan all the way through, except for the last 2 that I reserve, up to the end, like the last 4 is what we'll index on, at least currently in my current code. And last I will be set to this, the index of this 4 here. Which in this case wouldn't be bad, because we happen to know the other candidate digits that are bigger than that are over here, for the tail end of our digit. Let's look at the other example here. Right, we reserve the last 2. All right, we scan the I through. We find 9 is probably the biggest digit. So we're going to take that as our first digit. Then we're going to scan for the next biggest digit we can get. That would be this 2. And then maybe on the sub part, we're going to scan again for 1 more, and we find a 1. That'll fill in 3 digits. Okay, so I think the first part is pretty still good, as long as we reserve enough digits. The strategy could work, potentially. So I'm not going to go first digit. So our first thing we need to do is our offset here. And I think we're going to call that largest, or stir too tall to end. No. Call it reserved. As I've been calling it as I've been talking about it. That's going to be digit len -1, because we're going to always pick the first one off the top. And so that reserved is the rest. A little space. I have a comment to remind myself what it's for. Something like that. Hopefully that's helpful for future me. Okay, and then we go to numlen minus reserved. It's not one character anymore, it's the reserved characters. And I think this algorithm will still work for 2s. We compile this now. Yeah, it still works for us. Haven't changed anything yet. No changes behavior. At least in this particular case. Okay, so the meat of it is going to be changing this part down here. All right, so we're still going to start after the largest I and sweeping through to find the next largest digit, but we're not going to be done yet until we filled all the digits in. So what we could do is reserved is how many digits we have left to fill in. Actually, that's probably a better comment for myself. Okay, so it's our remaining digits to fill in. so while reserved is greater than 0, well, that means we still have digits to fill in. In fact, reserved is probably too much. Maybe we should call it remaining. And that's a little bit more obvious. We'll change that there. Yeah, I like that. Happy little variable. Self-documenting code. The dream. The dream of dreams. Like, I read code, but I don't, like... It's not like reading a book. It's a bit different. So while we have remaining digits to fill in, basically... So we got to keep using largest I to shrink down remaining. All right, we're gonna have to do something with remaining. We have to keep shrinking it down so that we hit our terminating condition eventually. Okay, so this part now, we need to do something with remaining. So we're gonna go from... Yeah, from largest I plus 1, the next one after the digit we just found and filled in, up to the end. That's still fine. If we find a bigger digit... Okay, we set... Not just digit 1 now, but we have to set the digit after the one we just filled in. So I need a variable for that. A little hole there that doesn't work, so the files here. So I need... How am I going to fill that one in? And it's here as well. I'm going to call it digit I. We filled in the first digit already, pre-filled, so that's going to be 1. In fact, largest I might even be... The one we filled in. No, it's got to be the next one we're looking at. Call it next digit. What did I want? That's what I want. The next digit to fill in is what we're looking for here. So in our game, we found the best one, now we're just looking to fill in the rest. And we're going to eagerly, again, greedily, look for the next best digit in the next column of our output number, the next highest one. Right, which should be, initially is going to be, mem set it all to, actually it should be that. Zero would probably be just fine too, but it all works. So then next digit becomes the digit we're looking at because we found a larger one for it. Now when do we increment next digit? I guess after we get through this loop, right? kind of makes the most sense. I think that seems to make sense, right? Because we sweep through. All the way through. We visit every single one in the remaining sections. Say that's what's remaining. And we get to the end, and like the largest one we found and largest eye would be set to this 2. And so we make that would be the digit that we set in next digit. And so I think that would make sense that after we're done sweeping through, we've seen all the digits. And so the next one is going to be that. Yeah. Okay. And hey, Crazy Wolf 770, welcome to the stream. Yeah, try it out. It's it can be challenging. There's also like some things that are kind of convenient about it too. Like that's my input parsing. It's through my file. It's pretty straightforward. You know, small amount of code. I think what gets a little bit challenging though is just like getting to know these functions really, really well. Like I was saying at the beginning of the stream there, fgets will get you a line, right, from your input stream. So the end line, anything up to an end line character until end of file, which actually probably should be checking for like does not equal to EUF in the file. Doesn't really matter in this case, but it still works. Anyway, but it includes the end of line character in it, and I was writing a bunch of code that assumed that was like stripped off, and I was getting just the string up until the end line, but not including the end of line character. So that's why you have like little bits like this. But otherwise, like pretty convenient. But yeah, like one of the things that you struggle with a little bit is like buffer sizes and like copying data and stuff. A lot of like dynamic languages are very convenient for that. Yes, all this code is up on GitHub. I'm Agent Ultra on GitHub as well, and all the code that I'm doing for Advent of Code is on there. At Advent 2025. So normally on the stream I do a lot of functional programming, but yeah, it's chaos time. It's that time of year where chaos must reign, and we must choose to use C for masochism reasons. And the learnings, always the learnings. Right, you learn stuff by doing things in other languages and once in a while. So yeah, so now we got to update digit, next digit, as long as it's within our range. So digits lang, it's gonna be less than or equal to digits lang. So if I say 2, I want exactly 2 digits. Otherwise, this could be a terminating condition here. We have no more digits to fill in. For our loop. We also need to resize remaining. Yeah. Oh, super convenient. 100%. I agree. You know, doing AOC, I've done them in the years past in Haskell. Super convenient a lot of the time, right? Um, yeah. If you're doing any kind of like DSA type stuff, like if you're leak coding as well and grinding that or whatever for funsies, doing competitive programming, C is not usually recommended. Because those languages have like data structures already kind of built in. You got your maps and your queues and all that sort of stuff. Um, you know, copying strings around is like, and like even changing a value into a string in order to do regexes on it, like some of the earlier puzzles this year. Way more convenient in those languages for sure. And so if you just want to like go fast and have fun and mess around, I highly recommend doing it in scripting languages. I don't know why I'm doing it in C, other than chaos. Yeah, so this could be like a terminating condition here for us. If we have the next digit, we have no more digits to fill in. And our other one is we got to shrink remaining as well, which is like our main terminating condition. So we could exit early here. Yeah, yeah. C++, big templates. Yeah, like C++ is a pretty good language. Like a lot of competitive programmers really enjoy C++. And you can see why if you ever watch the videos. Like Erlicto. It's not... I'm not really like trained to be a competitive programmer. I've never been a competitive programmer. You know? I've never actually like been to university and spent like 4 years just doing DSAs or whatever. It's all stuff I've learned over the years and like taught myself, and like I enjoy it every now and again, but yeah, it's super not my thing, so I struggle with it a little bit every now and again. But I'm learning. Like I every time I struggle with it, I learn something new, right? Uh, you ever? I don't know if you're a gamer, but if you played like Dark Souls, it's like one of my favorite video games. It's philosophically taught me a lot about like, you know, not giving up. A lot of animes have the kind of similar stories, you know. You get knocked down, but you can always get up, and every time you get up harder. Yeah, man. PS3, Elden Ring. Oh, so good. Been playing a lot of Night Rain with my boys. But I love those games. Same thing with data structures and algorithms, right? Don't let it get you down. You know, if you watch a lot of YouTube videos and you watch a lot of competitive programmers, you can think like, oh man, if I got to be a good programmer. If I'm a good programmer, I got to be able to do this. But it's a skill. It's a very specific skill, and it's not one you generally use in your career as a programmer. It's usually something you could do for fun, or something you might do in university, or like if you're interviewing. But yeah, but still, you learn a lot of neat stuff doing it, so it's kind of fun and worth doing, in my opinion. So now we got to shrink remaining. So what's remaining gonna be? After we found the largest I think it's going to be that index plus 1. Subtracted... How did we calculate it? So that index plus 1 subtracted from the length, right? Digit length. As initially. I wonder if I'm setting remaining... I think initially we're initializing it to the right value. That feels like that's right. Because we're using it as the terminating condition for this first loop to find the first digit. But something feels weird about it now. Because I gotta shrink it by a certain amount. How do I know how much to shrink it by? When all I've got is largest I here, which is just some index in the array. Well, actually, remaining and next digit are almost... It's like, maybe remaining is just... We filled in a digit. Remaining is the remaining digits we need to fill in. So we just shrink remaining by 1. But only if we filled it in. Maybe that's the key. Okay. We might want some asserts here, potentially, but let's see. Largest I should be... We only set it the last time we're through this inner loop here. Yeah, so that should be the last index we filled in. Get our string, our number, and all that stuff. Okay, let's compile and see what happens. Oh, we're not... Well, we should not change behavior, existing behavior, but we do. Which is no bueno. It's not quite right. Because digit lang is 2, yeah. So initially, remaining is going to be 1 in our example, our current program. Okay. So remaining is greater, 1 is greater than 0, so we're going to do 1 loop through this. In that loop, we go from the largest I, which is originally going to be set from here, I plus 1. So that first one after it. And then we go up to nunlen. It's up to the end of the string in increment I, looking for the next digit. Next digit is already 1 because we filled in the first digit 0. Okay, so we set it to that to be num I, and then we set largest I to be that. Now, that should go and set the next largest digit. And let's do a smaller test here on just one of these. This one got the right answer. We'll get one with the wrong answer, like this one. Okay, 81, right? Ah, that's not getting the whole string. Where am I printfing that from? Here. Oh, because, yeah, my echo is not included with the new line character, sorry. There we go. It's not quite Right, either... how do I put in a shell? A literal new line character in a string. Ah! Okay, we're just gonna have to go with having the test 3 days. Okay. So it actually gets... Wait. What? Something between there and there. Now it's... working? Question mark? What did I change? Was anybody watching? Weird. Okay. Okay, it gets the right answer. Okay, for 2. Now that we have our changes. Okay. So let's commit that. Ah, Bit Rider, thank you for the follow. Made a great decision today. I usually do a regular stream on Tuesday evenings in the Eastern Standard Time Zone. It's my regular. I'm just doing extras this week and maybe next week too for Advent of Code. So yeah, thanks for the follow. Appreciate it. I don't mind any backseat programming, by the way, or like, probably don't spoil the puzzle if you've already solved it. But or if anybody has questions, wants to dig into something, all good too. Work in progress. Dynamic tail thingy. Okay, so the next stage, now that we got this going, is to see if we can make it work for 12 and sum up those numbers, those jolt numbers for the puzzle. So I'm going to rename this as sum part 1. Jolt num 1. And then I'll create one for sum part 2. We'll do num2. I will do max joltage or buff. Our buff len 12. Let's see if our algorithm works. Sum part 2. Jolt num2 there. Put that out. Oh yeah, part 2. That'll be part 1. Semicolon, a little compile, a little test. Okay, we got some big number. I'm seeing some worrying results here. That doesn't look right. Okay, so for an example, this subpart of the string here is our maximum joltage. We should get that. And we do. But in this case, we're not getting this one. Okay, we're getting this weird number, which is not great. And same for this one, we're not even getting close. I think we should get that. Okay, so something with our remainder remaining is probably off, I would say. This is going to be probably the most interesting case here. But it should be fine. So our initial strategy goes through the whole list and tries to find the biggest thing. But it's not going through the whole list. It's going through the whole list minus the number of digits we want to fill in. Or it should be, at least. Looks like we're making some progress on it, but we stop early. Somewhere. What's my time like? Okay, I got a little bit more time to put into this stream. So let's keep going and see what we can debug here. Okay, so maybe our terminating condition shouldn't be... Should it be remaining? Alright, I've got this extra code down here. Kind of checking a terminating condition and breaking early. Maybe it should be remaining digits. Or next digit. It should be this terminating condition here. Next digit. I should just lift that up. That could be one thing. Yeah, so I'm going to make that change and see if that works a little better. And maintain. It might not give us the correct answer for part 2, but it should maintain the answer for part 1 if I'm right. So let's go. So what it would be when next digit is equal to digits len. Digit len. I made next digit. There should probably be similar types. Okay, and I'll just be extra careful. I'll assert next digit is less than our string length. Okay. So that completely changed the part 1, so that's not the right answer. Oh, well, it equals that. Oh, okay, that's silly. Sorry, less than or equal to. And then we have to change next digit, which we kind of do. No, we don't. We miss, so we got to do that. Next digit is plus. Oh, we're getting an infinite loop. Okay, we could get an infinite loop because we're conditionally increasing next digit. Yeah, so if we don't always increase or change next digit, we can end up in the situation where this loop doesn't terminate. Let me back up to where we were. Try a different approach. Still like that change, though. Create a little code for that. Okay, let's see. So remaining is our terminating condition, which I think works for the first digit, right? We run, oh, sorry, we compile this. We get bad results, but I think the first digit is always the one we want. 92. In this example, should be 4, yeah. And 78 on the first day. And for this number, 8 should be the first digit, yeah. So I think that strategy is still working. Why is it working for this one? Is it the same length that we expect? And yep, okay, same length too, okay. So that's good. It's just in these cases we're not getting it. The remaining cases. So it just happens this one's right. Which means the algorithm is wrong. Okay. Let us, after we pick the first digit, before we get to remaining, let's just check our state. Remaining. We'll get largest I. And next digit. Well, next digit will be one. It's kind of fixed, static. We don't change it. So largest I. What else do I want to see? I want to see the length. Nunlen, I'm pretty confident I know what that's going to be. Let's just print out the num string though, for convenience sake. Yeah, Nunlen, why not? Okay. He is complaining at me. Oh, oh, yeah. Something has size T. Numling. Pass it to enter. Okay, sure. File, run it, okay. So after selecting the first digit, which we know is doing, or at least we believe is doing it correctly, and we're doing what we want. I'm gonna turn off the other printfs because that's annoying. Okay, so we have a value of remaining 1. Largest I was at 0. That seems right. Kind of what we expect. And in the second case, remaining should be 11. We wanted 12 digits, we filled in 1, so yeah, 11 makes sense. The largest I was at 0 again. Okay. Here, again, part 1, remaining 1, largest I is correctly 0. 8, because we only consider the first, those digits, the ones highlighted, not the 9. And in the second case, 0 again, largest I, that's correct, remaining 11. So this state's all looking pretty good so far. In this case, remaining 1, largest I was 13. Largest I was there at the 7, yeah. And remaining 1, so that's fine. Here, we get the largest I of 2. It found to that 4 here. Right? Let me make this a little bigger. How did it... Oh, that's not the right number either. Let's look at this one, yeah. Right. Found this 4 here. Right, 0, 1, 2. That's because the length of this was 15, right? Let's get rid of you for a second. Yeah, 15 and remaining 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, we can only look at the first 4 numbers to find that. Alright, so I should have ended on this first 2. Okay. Which means largest I is 2, yeah. So we can start looking at 3 and onward when we go to our next step, right? And start searching the rest of the numbers. Which... we do here. Okay, this kind of doesn't really make a whole lot of sense to me now. Because we set the next digit up here. And this is all going to be true as long as we have digits to fill in. We're always going to increment that next digit. You know, possibly regardless if we filled anything in. So that might be why we're getting all those zeros in our output. But the initial state, at least, before we go into that loop, is looking pretty decent and pretty good. Okay, so that part, up to that part, we're good. Okay, so then, how do we keep searching for our next digit to fill in and make sure that we actually end up terminating? So I think we do have to shrink remaining, and that remaining should be just like we did for I, maybe a part of our inner loop condition here. Although it doesn't really need to. In fact, remaining might even be a bit of a red herring. We just need to know... What do we need to know? We need to know the next I, which would do the largest I, that we can start from, and how many digits remain to fill in. That's it. Or how many digits... And we can... Yeah, how many digits to fill in. And we can know that by the next digit we have to fill in... Now we know that there's always going to be enough digits to fill in. If we choose 12, as long as 12 is less than, as long as the length actually is less than length. So we might want to put that in there as well, like just to be complete. Not that this puzzle input would do that, but it could be equal to numlen. If it's equal to numlen, then we just return num. Some kind of error condition. Okay, so let's try the next digit again as our terminating condition. So, knowing that greater than, it can be up to equal, which is what we had before. Less than our string length. Now the thing we're struggling with here is getting that. And if we print it out, never gets incremented. Because we never change it. Let's change it here. And it always hits 15. Never terminates. Because we never find a digit less than or equal to num length. We'll never increase it past that because we'll never visit that character past that. Okay. So... Because we have to have at least 2 digits. At least one we have to find. Okay, that one's stuck in at 3. No, it shouldn't be numlen. It should be... What am I doing? It should be digitlen. Okay, 2, that's fine. At least in some cases. Somehow that one gets, that one gets, that one gets, but this one... We get next digits. Okay. Digitlen. And up 2. Yeah. Digitlen of 12, and somehow we get next digit to 15. So something is funky with... So in the case of 2, if we start off with 1, that's an index. So next digit is an index. Let's not confuse it with the length, right? So the digitlen is that. So should be less than. There we go. These don't look the right numbers for the test data, though. But it's terminating. So we're just going past a boundary now at this point. So then, day 1, we wanted 2, right? Digit length of 2. We end up with next digit 3. After we get out of a loop. Alright, that makes kind of some sense. So every time we start with next digit at 1, every time we find a number bigger than the one we're looking at, which in this case, in the first iteration of this will be 1, we assign that in the digit array that we've created, and set our largest I, the index of that character. And then we increment next digit to look at that. So when we finish this loop, in the case of 2, well, we could get to 2. We can get next digit less than digit length. So digit 1 is less than 2, so we would get the first loop And we'd increment that to 2. So this should terminate. How are we getting greater than? I'm going to create that assertion here. Before we even start any code. Okay, I'm not crazy. Okay, so that's not what's doing it. That's not how next digit is getting. What am I printfing there? Next digit. Oh, No. Maybe we should move that down here. Yeah, I think that might be what it is. Let's compile that. Yeah, there we go. Okay, so that inner loop is, yeah, increasing it multiple times. And that's how we get past that invariant, the loop invariant. So what we need to do is break out of this inner loop once. No, we need to go through all the way through, don't we? Maybe we do have to increment it here and trust this loop. So we're always getting incremented, so the assertion should be less than or equal to, because on the final round we might end up there. Okay, we got the right answer there for 357. So we're back to at least the test stuff working. Did we get it to work for part 2? No, we did not. We're a bit off. Okay, so at this stage, now I'm not looking at the next digit here. I think the loop is maybe not the problem, quite the problem here, but it could be the digit we're assembling, and getting back from string tall might not be quite right for some of these bigger ones for the 12-digit case. If we're getting the sum is a little bit off, right? It's in a ballpark. It's pretty close. So either we're not filling in all of the digits we need to be filling in, or the result we're getting back from string tall is off. So let's bring back this one. Yeah, so we're definitely way off here. Still not filling in all those digits properly, or I'm not setting the... Let's close that. I'm not setting the end character string in the right place at the right index. So we know from digit how long it's got to be. Right, because we allocated here to digit len. We should allocate it to digit len plus 1. We can memset them all to the 0 car and initialize the first digit. That's fine still. Then it should be that the final character would be digit len plus 1 to be the terminating character, so that we get the string tall there. Almost, no. This one. A little different. Okay, that messed up the other one, so that change wasn't quite it. Is it digit ling? Plus 1 bytes. Okay, 357. Okay, yeah. That's better. But that result is still good, but the other ones aren't filling in quite nicely. This one's filling in some of the way. Okay, I think all the other thing that we need to change is where we're starting from. No, largest I. We mutate that. So the next go around when we're finding the next digits to fill in. We're good there. Let's create a little community commit here. Work in progress. Better terminating conditions. And string stuff. Okay. So it's just these particular cases I need to look at here. Probably got about 10 more minutes left on the stream for y'all. Okay, so it looks to me like this code isn't filling in all of these numbers. We should see all these end zeros in. If we're looking to fill in 12 digits, we should have 12 digits. And no zeros. I don't think there's any zeros in our input. So we could trigger a exit early and print out some state if we detect any zeros in our string, and then print out some state there. See what the heck is happening. Or we could just narrow down our test file to like maybe 1 and try it that way. I'm just going to look up how to echo new line literal in bash string. Dash E. Oh, okay, that's what I was missing. All right. So let's echo just one of the test cases. That is not looking right. Dash E, so put a little N on the end there. Oh, doesn't. Did I look that up from AI? I was getting that from AI. Why does that? It's always almost, it's just wrong a lot of times. Oh yeah, it should be dash E, what the heck? Maybe my weird terminal? That's fine. Okay, it's probably just Emacs then. eShell. Okay, so I'll do the testing my little terminal down here. So that number /n, pipe it into bin day 3 voltage. Okay, I'm gonna comment out the part 1 usage. Okay, there we go. So before we start that loop, we should have numlen 15, remaining is 11, largest I to be 2, and digit ling to be 12. I'm going to print out our state every time we enter the while loop. What do we want to know? I want to know what the current largest I is. Yeah, what next digit is. Okay, so it goes through. Largest I starting at 2. And the next digit is at index 1 that we need to fill in. Then we find a bigger digit at 14, and our next digit becomes 2. And the largest I is 14 again, and the next digit becomes 3. So nothing changed except for next digit. We're incrementing it regardless. 14, 14, 14, 14, 14. All the way through until next digit becomes 11. We terminate. No. So we're not moving on after a certain point with largest I. Because we don't change largest I. Unless we get that one, which are due to 14. And then next through this while loop, we come in again. Largest I would be 15. And then we never enter this loop again, and we just keep incrementing digit plus plus. Okay, that makes sense. So why did it jump to largest I at 14? 0, 1, 2. So started at the 4. And so we went from 0, 1, 2. So we went from 2. So we went from 3 onwards to the end and found the biggest number would be 8. Okay, the next biggest number would be 8, so which is not right. Okay, that's where our strategy is falling over. So I think we still need to use remaining somehow. All right, because if we start at the... Let me bring up this number. Make it a little bigger and like talk about our game strat here. Here. Okay. So we stop with I here as our first digit, and then our second loop is going through the remaining digits afterwards. Right, but currently it's trying to find the best digit that it can and then stops there. Which would be 8. But this is not necessarily right, because we got to leave space for the other digits we still have to select. In the future. So we selected 1, remaining now would be, well, originally our remaining was like what, 12, right? Or no, 11. So we were able to select for I from 0 up to an index less than the length minus 11 digits. So like something around here. These are you're not allowed to look at. And it found 4. So now what we got to do is do a similar strategy for the next number, but remaining decremented. So that we consider all the numbers from this index onwards, from this index here onwards, minus the remaining numbers, like 11. It was 11 before, so maybe it's like 10 now. All right, so you can look at one of these two, because I think in the output that we know is correct from the examples for this number, 3 would be the next number to pick. So I think that's probably how that's going to go. And that would do it. Yeah. Yeah. Okay, let's see if I can get this before I go. I'm running short on time. Okay. So let's decrement remaining, as we've picked one. Okay, and so in here, our search condition here needs to be up to numlen minus remaining. And then, I think this should be fine here, but if we do that, we go remaining minus minus after we pick a digit. Our while condition might still be good. Let me do my little test. So at least we're filling in all the numbers. No more zeros. Probably not the right number though. Let's check. Maybe it's the right number. Oh, actually, yeah. 434234278. Yep. Okay. Let's check a couple others and then run the full test. Let's just run the full test. I've got a bunch of printfs in there that's going to make it messy, so let's just spot check a couple and then we'll clean it all up and see if we can run the full test. So that one was kind of weird. This one wasn't good. Let's test that one. In pipe in day 3 joltage. I think that's the expected result. Okay. Good. Let's clean up the code. Get rid of our debugging. Or maybe comment it out until I'm like happy with it, in case I want it back. No, I'll leave this one in. Okay, is this close to the right answer for the test input? 8619, 8619, 31219, yeah. Okay. Good for the test input. Let's do the full. Oh, I don't have the test. My test input data on this one. Puzzle input. Data 3 next. Oh. Oh. Okay, a lot of printf still in there, but okay. The moment of truth. Am I gonna get burned, chat? Any voters? Is it gonna be the right answer? Are we confident? Let's go. Hey, it is. There we go. Awesome. Gold star. So let's just clean up that code. Let's create the final commit, squash all that junk down, and call it a morning. Okay, looking okay, looking okay. Bring part 1 back in. That's nice. That's nice. Okay, let's compile. Check what our output looks like now. I'm still, where do I got it? Here. Go. Oh, that's the that's the test. More like this. Okay, yeah, good. Yeah, we're still good there. Okay, cool. Yep. I like it. Okay. Looking clean. Looking good. All right, commit. Solved it. Banger. Squash this all down. I'll pick or reword that one. Yep. Modify. Force. A3. Joltage. .c. Solve part 2. Push it up. So like I said earlier, in case you're tuning in after and you've missed it, all this code is up on GitHub. I'm Agent Ultra. You can find the code for my Advent challenges there. I'll paste that in chat. I usually do this stream. My regular is on Tuesday evenings at 10 after 8 in the Eastern time zone. You can find me on the Fediverse, on the types.pl server on Mastodon. It's got links to all my stuff, or agentultra.com. Also has got links to all my stuff. Where I back up my VODs on YouTube, on my YouTube channel. You can find my GitHub and links to all my other stuff there. You can follow me here if you like. You know, I usually post tech stuff. I try to content warn if I'm like posting outside of tech things. Not always great at it, but I do my best. And yeah, updates on the stream and stuff. If you want to give me a follow here on Twitch, that's great. You'll get notified if you have your notification settings set up when I go online. Otherwise, hopefully we'll just see you next week. And if you're on watching my VODs on YouTube and stuff, you know what to do there. Like, subscribe, and ding the bell and all that stuff. It's already 6 p.m. where you are, Crazy Wolf. Well, it's always 6 p.m. somewhere, isn't it? That's awesome. It's middle of the day here for me. I'm going to go get some lunch and stretch. And I might start working on part 4 this afternoon, but I don't know if I'll stream it. But maybe I will. I don't know. So, anyways, yeah. The link above my head goes to a cool website called declarative.tv, run by some other cool hackers in the scene who are doing stuff in languages like Elixir, Erlang, various other declarative style languages, including Haskell as well. They're all streamers, so go check that out. It's also got a link to a Discord server where we have a channel for this stream. So if you want to chat about your projects or anything you've maybe thought of later that you wanted to ask but didn't have time to, or whatever, I don't know, you can ask it on the stream and hang out and have fun there. What else? I think that's probably it. Why don't we go find someone to raid and be on our merry ways? It's been great. Well, thanks for the follow, Crazy Wolf. Hope we'll see you around again. It's been great having you on the stream. All right, some game development maybe. Syntax, semantics, and strong coffee. Ooh, that sounds cool. Hopefully they're online. Yes. Tienta, we're coming in. We're gonna raid Tienta. Give Tienta, if you like their content, a follow, share the love, the Twitch love. Quite diff in the time zone. Right on. And it's been nice hanging with you, Crazy Wolf, as well. And everyone else. We're going to start the raid. So yeah, give them a follow, spread the Twitch love. And we'll see you next time.